Today we're going to talk about arc length and sector area. So what is that? Well, first you should remember that for a circle, we're talking about circles or parts of circles. A circumference is calculated with 2 pi r. The area of a circle is calculated with pi r squared. And we're talking about arc length. Well, what is an arc? It's a one-dimensional connected subset of a circle circumference. So if I take this part of a circle, um, it's just part of the circumference. For a sector, it's two-dimensional, and it's the region bounded by two radii and an arc. So we have one radius, a second radius, and an arc. That's two radii and the arc. This is we're looking for either the area of that sector or the length of that arc. The big idea is that they're proportional to the circumference in area. So you want to figure out how much is the entire circumference, and then what part of the circumference is this arc length. Same idea with the sector area. What's the entire area, and what part of the area is this sector? Well, specifically, if it were the whole thing, it would just be times 1. If it were the whole 2 pi angles, 2 pi around. But if this angle is theta, well, we're going to be multiplying by theta because it's going to be proportional to that angle. And if it's the whole thing, we want this whole thing to be 1. So we're going to do theta over 2 pi is the factor. So if this were 2 pi over 2 pi, then we'd have the whole thing. If this were 0 over 2 pi, then we'd have no area or arc length. So this is the factor that takes the whole area or the whole circumference and turns it into the arc length or sector area. So what that means exactly is that the length is 2 pi r, the circumference, times our factor of theta over 2 pi. And the sector area is the whole area, pi r squared, times our factor of theta over 2 pi. If you want to memorize these formulas, you certainly can, but typically it's easier to just say, well, those 2 pi's cancel out, and the arc length is r times theta, where theta is in radians. The same thing goes for sector area, that the pi's cancel out, and we get that the area of the sector is r squared theta divided by 2, where, once again, theta is in radians. If you have things in degrees, you can either convert them into radians, or just instead of using theta over 2 pi, use theta over 180 degrees, and you'll still get the same idea. So let's apply this to a problem. The arc length of an arc measuring 50 degrees is 48 centimeters. What is the area of the corresponding sector? Well, we have the arc length is the radius times our angle in radians. So 48 centimeters divided by 50 degrees. Well, 50 degrees is 50 degrees times pi over 180, because that's how we convert from degrees to radians, equals the radius. So we can use this expression as the radius. And then for the area of the corresponding sector, well, that's r squared theta over, what was this, pi? No, over 2. So r is this whole thing over here, 48 centimeters. I'm not simplifying it because I don't have a calculator. I mean, I do have a calculator in the computer somehow, but it's really hard for me to actually pull it up. And then this is squared, and then theta is 50 degrees times pi over 180. Certainly these problems are easier when you're given them in radians, but either you can just convert this into radians first, or to get a more precise answer, you can substitute them in and then evaluate with a calculator at the end. So this is your answer, and you can do the arithmetic with a calculator to find exactly what the area is. So again, this is 48 centimeters over 50 divided by 180 pi squared times the angle, again, 50 pi over 180, and then divide the whole thing by 2.